So, okay, Nawal and Matthew. Hmm. So, I will discuss today what is Biot law. Okay, in the last class, I have discussed what is the magnetic field and what are the sources I have discussed. And in today's class, we will discuss how we can calculate the magnetic field. How we can calculate the magnetic field. Guys, are you getting my voice clearly?
Yes, sir.
Okay, fine. So write down the heading. This heading, Biot law. So this law is used to calculate the magnetic field due to a current carrying wire at a point. Due to a current carrying wire at a point. Okay. So suppose you are having a wire like this. This is the wire you have. Okay. This is a wire, and in this wire, the current is flowing like this. I current is flowing like this. And if you want to calculate the magnetic field, suppose at this point, if you want to calculate the magnetic field at this point due to this current carrying wire, then then Biot is the name of the scientist. He has given the expression. He has given the expression. So he said that you cannot calculate. Suppose this whole wire is AB. Hello Nawal, how are you?
Hello, sir.
So I am discussing Biot law. Okay. So please, I have just started. So here is a wire we have. Suppose this wire is AB. This wire is AB. Whole wire is AB. And in this wire, the current I is flowing. And I have told you that due to the current also, the magnetic field can be generated. I have told you. So here is the current. So magnetic field will be generated. And that generated magnetic field we have to calculate. That generated magnetic field we have to calculate. So Biot was the name of the scientist. He has given one of the expression to calculate this magnetic field at a point. Okay. So if you want to calculate the magnetic field due to this whole wire, you cannot calculate that magnetic field with the help of Biot law. You can only calculate the value of magnetic field due to the very small element of the wire, dl. Dl is the very small length of the wire. Okay. Due to this small length, and this is a small length of the wire, and in this small length also the current will flow, because current is flowing in whole of the wire. So in this small length also the current will be there, and due to the current in this small length, there will be a magnetic field at this point. Okay. So due to the current element, and this is known as the current element, this dl na is known as the current element, ideal. So what you will do, you first measure the distance from here to here, means with this dl and this point P. Okay. Suppose this is a distance r. This is a distance small r from this dl. Okay. And this is the angle theta I am taking. and this angle theta I am taking. So this theta is like this. This theta is in between the angle between DL and this R. Okay, this is the theta. This is a point P. So the angle is between DL, means the small length of the wire, and the distance R. So this small and this element of the wire is small. So due to this small element of the wire at this point, which is at a distance, general point, which is at a distance R, will be small again. So small magnetic field is directly proportional to the current flowing in the wire, a small elemental length of the wire, and sine theta, theta is the angle between the DL and R, divided by R square. So this is the expression given by the Biot. So means the small magnetic field is directly proportional to current and all these quantities that I have written. So I is the current flowing in the wire. I is the current flowing in wire. DL is small length of wire. Theta, you can write theta as, I am making it a vector. Also, I am making this R as a vector. Just wait. I will explain each and everything. R vector. So, for the vector, there is a requirement of two things. One is the magnitude, other is the direction. So, for this DL, for making this DL as DL vector, for making this DL as DL vector, there is a requirement of two things. One is the magnitude. So magnitude part means the magnitude means the numerical value. Numerical value you will get from this DL. DL is the numerical value. And for the direction, you will consider the direction of the current. Okay. So this is the DL vector. And R is the position vector. Okay. So theta simply you can say is the angle between DL vector and R vector. Okay. And R is the position vector. Okay. Or when you will take the just magnitude of R vector, you will get this distance R. Actually, R vector, if you will take the magnitude of this R vector, then you will get R. And R vector is the position vector. Position vector of point P. Now we have this. Okay. This is given by Biot. And when you will remove this proportionality sign, you will get a constant, and this formula will become Ki dl sine theta divided by R square. And in SI unit, SI unit means International System of Units. Okay. So there are two types and many types of systems of units: SI unit, CGS unit system, FPS system. So generally we prefer SI unit. Okay. So in SI unit, the value of this K is mu naught divided by 4 pi, and this value is given by 10 to the power 4 pi. 10 to the power minus 7. Okay, 10 to the power minus 7. And the unit of this is Tesla meter ampere inverse. Tesla meter ampere inverse. Okay. And what is this mu naught? In Coulomb's law, there is one thing epsilon naught or epsilon 0, and there epsilon 0 is the absolute permittivity of air or free space. Here mu naught is the absolute permeability. Absolute permeability. Then we will discuss the magnetism or natural magnetism, you can say. Then we will discuss what is this in detail about the absolute permittivity and relative permittivity and all that. This is absolute permeability of air or free space. So finally, your formula will become dB is equal to mu naught divided by 4 pi IDL sine theta divided by R square. So finally, your formula is this. Okay. Finally, your formula is this. So this is the formula for the magnetic field at a point due to the small element of the wire. Okay, you cannot calculate the magnetic field due to whole wire with the help of Biot law. Okay, like Coulomb's law is for the point charges, na. Similarly, Biot law is calculating the magnetic field for the smaller current elements. Okay. You are, suppose this is the wire, and in this wire there is a current. Okay, so you can just calculate the magnetic field due to the small length of this wire with the help of Biot law. Matthew, completed?
Yes, sir.
Okay. Just please note it down. Then further we will discuss the vector form, and there are few other things also. When completed, please tell me.
Yes, sir.
Complete. Nafisa and Nawal, I think you have completed.
Yes, sir.
Yes, sir. Completed.
Very good. So now this is the formula, first formula that you have to remember. And with the help of this formula, you will only get the magnitude. You will only get the magnitude of the magnetic field, and this is the scalar form of Biot-Savart law. Which form? Scalar form. Why scalar form? Because you are just only getting the magnitude. Okay. Now, uh, in vector form, how you will write this? Like we have done the Coulomb's law. First, we have derived the Coulomb's law with in scalar form, and then after there is a derivation of Coulomb's law in vector form. Okay, so like this, first we have derived this in the Biot-Savart law in scalar form, and now I am writing in vector form. I am writing it directly in vector form. In vector form, if you want to write, then simply you will write magnetic field vector is equal to mu naught divided by 4 pi I into dl vector and r vector, but in the denominator this time you will have r cube. In the denominator you will have r cube. Someone can ask you why in denominator there is r cube. So just see here, when you will open this vector form na, when you will convert this vector form into scalar form, you will get this result. Just see here. If you have two vectors a cross b, then you should know that this is given by ab sine theta. Okay, sine theta is the angle between the vector a and vector b. Here are two vectors, so we will write in terms of ab sine theta. Okay, so I am writing it like this. So this is dl into r into sine theta divided by r cube. Now when you will cancel this r with r cube, so this power will become again this, so again you will get the same formula. And I is also there, so I dl sine theta divided by r square. Okay. So this form you have to remember, this form. This is the vector form, and when you will solve the question from this vector form, direction as well as magnitude you will get. Okay, so this is the vector form. Suppose if the examiner asks you that write the Biot-Savart law in terms of current density, in terms of current density. In terms of current density. When we were discussing the current electricity, there we have discussed current density, and current density is represented by J, capital J. Capital J, okay? This is J. I make J like this. And this current density is the current divided by area. If anyone remember, current density is current divided by area. Current per unit area is the current density. From here you can calculate the value of current. And what is your motive? Your motive is to convert this form in terms of this current density J. And this current density is again a vector quantity. I have discussed there. So when you will calculate the current, from here you will get J into A. Okay, you will get J into A. Okay, now you have the vector form. dV is equal to mu naught divided by 4 pi I dl cross r divided by R cube. Now when you will put the value of this current, when you will put the value of this current, you will get this JA. Instead of this current, I have put JA from here. And same thing, I will write here DL cross R. And in the denominator, we have R cube. So suppose you have a cylinder, suppose you have a cylinder like this. And suppose L is the length of the cylinder. Why I am telling this? And you will get to know. Suppose area of cross section of the cylinder is same. For cylinder, the area of cross section always remains same. If I want to calculate the small volume of the cylinder, so what I will do, I will take a small length of the cylinder. This is the small length DL of the cylinder. And for the small volume of the cylinder, dV is the small volume of the cylinder. What is the volume? Volume is the area into length. So here you can imagine when you for the area you can cut the cylinder into two parts and you will get again the area A, but the length will be DL. Okay. So a small volume of the cylinder can be given by A into DL. dV is the small volume. And when you will do further calculation, you will get this mu naught divided by 4 pi. And from here, area into DL means when you will open this DL R sine theta, then you will get this. So you will get this. I am doing it, no problem. You can write here JA and you can open it again. DLR into sine theta divided by R cube. This is mu naught divided by 4 pi. Okay. And this, what is this A into DL? A into DL is dV. dV is the small volume or elemental volume, you can say. Elemental volume dV. What is remain? J into DL and sine theta, and this R is remaining
Cancel,
here.
right?
Yeah. So you can cancel this R out from here. Okay. And this is dV. You will get here dV. A into DL is dV. And when you will just put this J, here you will have J and you have R into sine theta. Okay. And in denominator you will have R cube. So this JR sine theta can be written in the form of J cross R, means see this formula. This is the cross product. Otherwise you will get confused how I have written. I can write J vector cross R vector as JA sine theta. So for JA sine theta, not JA, JR, here R. I can write JR sine theta. Okay. So this JR sine theta can be written in terms of J cross R. So finally you will get your magnetic field like this. Mu naught divided by 4 pi. dV is the small volume and here you will get J vector cross R vector divided by R cube. So this is the magnetic field in terms of current density J. So now you can easily derive. Remember one thing, this chapter is mostly based on the vectors. Okay, because magnetic field is a vector and you should have a knowledge of the cross product. What is the cross product? What is the dot product? You should have the knowledge. I will tell you. Okay, and one thing more, the direction part of this is very important part. So this derivation, so you can do easily if you don't know. Means so we have derived the Biot law in the vector form. Means in the vector form you can write this as this, and in terms of current density, the Biot law will be this. Suppose if you are calculating the magnetic field in terms of velocity of charge. In terms of velocity of charge. So what does it means? Just remember that you are having a wire, and also you are having a small length of the wire. Okay, and you already know what is dl vector, and you already know what is position vector. So dl vector you know, and r vector you also know. Now what is the meaning of velocity of the charge? Now current is the flow of charge per unit time. Means the current is flowing in this wire, so you can say the charge is flowing in this wire per unit time. Current is simply the charge in motion. Okay, so when the current is I current is flowing in this wire, it means that charge will also flow in this wire. So if the charge is flow in this wire, then this in this dl length also there will be a charge flow. Okay, so I am supposing dq is the amount of charge that is crossing this dl length. Okay, dq is the amount of charge. Dq is the small charge, you can say, or charge. Passing dl in time dt. So I am saying in small time dt is the small time. Okay, like dv is a small magnetic field, dq is the small charge, dt is the small time. So from this length element, dq charge is flowing in time dt. So can I write the expression of current? Current can be written as dq by dt. Okay, current is charge divided by time. Okay. Now charge is flowing in this wire, so there should be the velocity of the charge. Okay, there will be the velocity of the charge or the speed of the charge. So for the velocity of charge, what is velocity? Velocity is the displacement divided by time. Okay, displacement divided by time. And what is the displacement? You have dl vector. And what is the time? Dt. So the velocity of the charge is given as this. And this velocity of the charge I will represent with v, the velocity of the charge. So velocity of the charge is given by displacement dl. Okay, means from this dl, okay, the charge is flowing with a speed of v. Okay, and this is given by dl vector divided by dt. Now you have to put the values on this. dv is equal to mu naught divided by 4 pi I dl vector cross r vector divided by r cube. Just put the value of current first. What is the value of current here? You can see the value of current I. Put here dq by dt. dq by dt. Okay. And now you have this dl vector cross r vector divided by r cube. I am just putting the value here. Now this dl vector divided by dt vector is v. dl vector divided by dt vector is v. So simply you can write the magnetic field or the small magnetic field due to the current element will be dq, and this dl by dt is v. So from here you can write this as v vector multiply cross r vector divided by r cube. So these two derivations the examiner can ask you with respect to the Biot-Savart's law. So you should know what is the velocity of the charge. How you will put the value of velocity of the charge, you should know this. And you already know what is current. Current is can be written as dq by dt. And now for any other medium, like for the Coulomb's law, in between the charge, when there is any other medium other than air and free space, then we use the relative permittivity or the dielectric constant. Here also we will use relative permeability. So for any other medium, then free space or air. What is the meaning of that? So this is the wire. Suppose you have, this is the wire you have, and here is a point, and in this wire the current is flowing in the upward direction. Okay, the current is flowing in the upward direction, and this is the point. Here you want to calculate the magnetic field. Here you want to calculate the magnetic field due to the small element of the wire. But right now between this point and this wire there is air only. There is air only. But suppose instead of air, suppose there are some other gases or some other medium. Can uh, other medium can also be there, Matthew? Mean it will, suppose this wire is in water, okay, and there is a point inside the water where you want to calculate the magnetic field, okay, then you will use this thing. Mu naught into mu r, you will multiply with it mu r by 4 pi.
So what would be the difference if we put it in a place other than free space or there?
What?
What would be the difference if it is in any other medium?
Just please speak loudly so that I can hear you.
What would be the difference if we if we use this in another medium? What would be the difference?
Yeah, that difference I am writing here. You in the formula you will get the difference. What you have to do, you have to just multiply this mu naught with the relative permeability. Okay, you will multiply mu naught with this relative permeability this time. Earlier you have a free space, you are using just mu naught. Now you will use mu naught with mu r. Okay, mu r will also be used and all the things will remain same. Matthew, got it?
Yes, sir.
Or in a scalar form if you want to write, then you can write like this: mu naught mu r divided by 4 pi, or this is ideal sine theta by r square. So this is a vector form and this is a scalar form, and this is valid. This is used when there is any other medium other than air or the free space. Like I have given the example. Suppose you have placed this wire inside some gases other than the water, other than the air and free space. Then you will, if you want to find the magnetic field, then you will use this. You will use this mu r, and this mu r is known as the relative permeability. Relative permeability. This relative permeability will discuss in the natural magnetism. Okay. Okay. Just copy this. Hmm,
So from velocity of charge.
from velocity of the charge. Nafisa, have you completed this in terms of the current density and this thing?
No, sir.
So just uh, I'm zooming it out, and all of you just please note it down. And directly you will get the derivation in your exam directly. The examiner will ask you derive the expression for the Biot-Savart's law in terms of current density for 2 marks. I have done nothing here. I have just opened this formula and but you should know what is current density, and you should know how to put the value in the formula. The main thing is that here, nothing else. If you know how to put the values in the formula, then you can do the derivation very, very easily. Now we will discuss the direction of the magnetic field, and that is given by the right hand thumb rule. When completed, Nafisa and Nawal, you can tell to scroll down. And please remember, this dV is the small elemental volume, very, very small volume of the cylinder. Or this is cylinder, na? This cylinder is a wire actually. We are taking cylindrical wires. You can see this wire also. This wire is also a cylindrical wire. Okay. Cylindrical means cross section of the wire will remain same. But you should know this cross product. If two vectors are written like this, A vector cross B vector, this is given by AB sine theta. And what is A and B? A and B are the magnitude of vector A and magnitude of vector B. And theta is the angle between the vector A and the vector B.
Done, sir.
Done? Okay. So just copy this. and examiner will ask you write the why I have done this derivation. Why I have done this derivation? I have done this derivation because examiner asked in the examination that express the Biot-Savart law in terms of velocity of the charge for 2 marks. DL vector is the length vector. Okay, DL vector is the length vector. R vector is the position vector. Some student thinks that length cannot be a vector, because length is a scalar quantity. Length have only numerical value. So if we give the direction to the length, then it will become vector. For the vector, there is a requirement of two things or three things. There are a requirement of three things also, but mostly there is a requirement of two things. First, it should have the magnitude. It should have the direction. So Matthew, can you tell me what about the current? Is current a vector or a scalar?
Scalar, sir.
We have discussed now in the current electricity about the current. Actually, current, if you are talking about what is the actual in actual what is the current? Current is neither a scalar nor a vector. Current is a tensor quantity, and tensor quantity is not a part of your syllabus. Till 12th class, the tensor is not the part. But for study of your syllabus, we consider current as a scalar. So, if in 4 options it is given that tensor option is given, then tensor option for the current will be more correct. Otherwise, from the scalar or vector, you will always tick the scalar for the current. Now we will use the right hand thumb rule to calculate the direction of the magnetic field.
Yes, sir. Finish.
Finish. Now finish this. Actually, the right hand thumb rule is derived from the cross product. This is known as the cross product. Completed, Hafiza?
Yes, sir.
Okay, so
Yes, sir.
now we will have the direction. Here till here I have just discussed only two things. Till here I have discussed only two things. First is this. And another thing is this. Oh, one thing is left here. Here is mu naught divided by 4 pi also. You can include. So here is mu naught divided by 4 pi I dl vector cross r vector divided by r cube. Only these two things till now I have discussed, and all the things I have derived with using either this formula or this formula. Now we will discuss the direction part. Direction of the magnetic field. MF means magnetic field in short form. From now I will write the magnetic field as MF. Okay. So this is magnetic field. Now direction of the magnetic field. How we will calculate direction of the magnetic field. First, always the direction can be given by the vector formula. Always. So write the vector formula for the direction. Mu naught divided by 4 pi into I dl vector cross r vector divided by r cube. And one thing more, if suppose you have a vector is like written like this, a vector is written like this, b vector cross c vector, then you can say the direction of this a vector will be perpendicular to b vector and also perpendicular to c vector. So you can say it implies that a vector is perpendicular to b vector and a vector is perpendicular to c vector. This thing keep in your mind. So here you can see this dv vector can be written as dl vector cross r vector. All things are constant here. Okay, this dv vector can be written in terms of dl vector cross r vector. So you can say this magnetic field, small magnetic field dv, will be perpendicular to this dl vector, and also this magnetic field will be perpendicular to this r vector. So you can write magnetic field is perpendicular to this is the perpendicular. Okay, I will write perpendicular like this. This is magnetic field is perpendicular to both dl vector and r vector. Okay, and you can also say that it is perpendicular to the plane containing dl vector and r vector. For an example, suppose you have this plane, and this plane contains one vector dl vector and r vector. So this is the plane containing dl vector and r vector. So direction of magnetic field will always be perpendicular to this plane like this. Okay, will be perpendicular to this plane. Perpendicular means this is the plane you have and the direction will be like this. Okay, now we will calculate, we will just identify the direction with the help of right hand thumb rule. First thing is you can find the direction if you know the cross product. Okay, and another thing, another part of the direction means to find the direction you will use, mostly now you will use right hand thumb rule. This is by cross product. This is the direction you are finding with the help of cross product. Now we will discuss right hand thumb rule. right hand thumb rule. So I have not talked about the direction of this. We have just find it the magnitude part from this formula, and for finding the direction we will use right hand thumb rule. And how we will use that right hand thumb rule, you can see first this wire. The current is going in upward direction and point is on the left side of the wire. This point is on the left side or the right side, Matthew?
Right side.
Okay. This point is on the right side of the wire. Okay, very good. So now see here, all of you. Just a minute. This is the wire you have. This is the wire you have. And tell me, this side is the right side or the left side according to you?
Left.
Yeah, left.
Very good. Now, this side is the right side or the left side
Left.
according to you? Left. Okay. No problem. So suppose you can just imagine this is the wire. No requirement of left and right side. Okay. This is the wire and the current is flowing like this. In the upward direction, the current is flowing. And before that, I want to tell you one thing more. Otherwise, you will get confused. I am just considering the plane of your this I have made on the screen. Na? This diagram I have made on the screen means always you will remember your screen contains the x-axis and y-axis. Or you can, when you will draw this on your paper, so you will say, you can consider your screen of your laptop or the screen or the page of your paper on which you are writing as same. Both will be xy plane. From now, I am just assigning the direction and we will use this direction throughout the chapter. So the x-axis and y-axis will be on your screen or on your this paper. Okay. So suppose this is your paper or suppose this is your screen. So on this screen, this contains the x-axis and the y-axis. Okay. So this is xy plane. Why this is xy plane? Because this contains the x-axis and the y-axis. Okay. That is why this is xy plane. And before that, please remember in the positive direction of x-axis, the unit vector is I cap. And remember that we will use the unit vector for the direction of the magnetic field. And in when for the negative x-axis, this is minus I cap. For the positive y-axis, this is j cap. And for the minus y-axis, this is minus j cap. So can anyone tell me where will be z-axis? If x and y-axis on the screen or on your screen, okay, then where will be the z-axis? Matthew?
Towards us.
Was Nafisa? What do you say about the z-axis? If I have considered x and y-axis on your screen, then where should be the z-axis? If this thing is not cleared, then you will get problem in solving the questions. Always remember, all the x-axis, y-axis and z-axis are perpendicular to each other. Okay, x-axis is perpendicular to y-axis, y-axis is perpendicular to z-axis, z-axis is perpendicular to x-axis. These three axes are mutually perpendicular. Okay, so z-axis will be either out of you or away from you. Means you can imagine z-axis like something is going into your screen. Something is going into your screen will be the z-axis, and I will represent z-axis because z-axis is a concept of 3 dimension here. In 3D you have to imagine. So I am taking z-axis like this, and this z-axis is negative z-axis. Negative z-axis is this, and along the z-axis, negative z-axis, the unit vector is minus k cap, and this is the positive z-axis. Here the unit vector is k cap, and this z-axis will be like this. This is your xy plane. Means x and y axis will lie on the screen of your laptop, and z axis will be either like this, means perpendicular to this plane, either coming towards you or either either going away from you. Okay, so this is the thing. And if something is going away from you or something is going into the screen, then you will represent that like this, or you will say this as inwards. So this here, this z-axis will be inwards. Okay, here if something is like that, this is termed as outwards, and this thing indicates that something is coming out of your screen towards you, towards the observer, or you can say something is coming out of your screen. So this thing is represented like this, and this is outwards. Okay, now I think it is enough. Now we will calculate the direction. We will identify the direction due to this point P. So what you should do for the, if you want to find the direction, what you should do, this is the wire and this is a point, suppose. What you will do, you will point your thumb in the direction of the current. Current is going in the upward direction. Point your thumb in the direction of the current. Point your thumb in the direction of the current, and point your this finger.
So I can't hear you.
Are you getting what I am saying? All of you?
Yes,
Point your thumb. I am saying all of you, Nawal, Nafisa and Matthew, point your thumb in the direction of the current. Okay, and point your fingers towards the point where you want to calculate the direction. So suppose I want to calculate the direction at this point. So the direction of my thumb in the direction of the current, and my finger is in this direction, where towards the point where I want to calculate the magnitude. And just curl the finger 90 degree. Just curl the finger 90 degree, and you will get this direction of the magnetic field. This direction. What is this direction? Direction is away from me. This direction is away from me, or you can say direction will be inwards. You can do it by yourself, please. Here the direction will be inward. Direction is like this now. This is going away from me. Away from me is means that something is going into the screen, na? So that here the direction will be like this, cross, inward direction. Or you can say the direction of magnetic field will be along negative z axis. Is it or not?
Yes, sir.
Yes, sir.
If you have understood this, then please tell me. Otherwise, I will explain it again. Because what you have to do, you have to point your thumb in the direction of the current and point your fingers, these four fingers, in the direction where you want to calculate the magnetic field, and curl your finger 90 degree. 90 degree like this. 90 degree means like this, na? And suppose if I want to calculate the direction of magnetic field at this point Q, can anyone tell me what will be the direction? Just take your right hand, okay, and this time the point is here, in this here, okay. So your finger should be in the your thumb should be in the direction of the current, and your finger towards the point where you want to calculate the magnetic field, and just point curl your fingers 90 degrees. So it is coming towards me. Towards me means out of the screen. If something is coming towards you, so it means that it is coming out of the screen. Out of the screen means outwards. So here the direction will be outwards, and outwards is represented by this. And this is represented by this is positive, along the positive z axis. Guys, are you getting or not?
Yes, sir.
Matthew,
Getting, sir.
Nawal, Nafisa.
Understood.
Nawal, have you got or not?
Yes, sir.
Otherwise, this will be very difficult for you. So just I am giving one question. Suppose this is the current carrying wire, and here is the current I. And suppose here is a point P. Here is a point P, and at this point P, I just only want the direction. I just only want the direction. So please, all of you, try this by yourself. Try right hand thumb rule. Apply right hand thumb rule here to find the direction at this point P of magnetic field. Tell me whether it is inward, outward. All of you can try. And one thing remember, okay, just please calculate that. After that, I will.
So can you repeat the question?
Okay. I am saying that this is the current carrying wire, and you have to calculate the direction of magnetic field at this point by using the right hand thumb rule. What is the right hand thumb rule? I have told you, point your thumb in the direction of the current and point your these fingers towards the direction where you want to calculate the magnetic field, direction of magnetic field, and curl it 90 degree. Then you will get the direction. So tell me the direction of this.
Out of the screen.
Yeah, right. Out of the screen. Means here the direction you will get outwards.
Yes, sir.
Very good. And outwards is represented by like this, na? In NCRT it is written. I have not represented this by myself. This is written in NCRT. If the direction is outward, then you will write like this. Is looking like this symbol are taken from. I will tell from where NCRT has taken.
So outwards is cross product, right?
Yeah, and outward means just something is coming towards you, or something is coming
Oh yeah.
out
Towards
of your
us is
screen.
like dot product.
Now, please, can
Into
anyone tell me? Can anyone tell me what is the direction of the magnetic field at this point Q? You have to just apply this right hand thumb rule. Nawal will tell what the direction here.
Inwards.
inward. Simply you can say if you are going on that side, that is outward. So how inward? Just see how inward. Inward means something is going into your screen. So you have this wire and you have to find the direction here. So what you will do? You will just point your thumb in the direction of the current. You will point your thumb in the direction of the current, okay, like this, and curl your, and this is a point, this is, suppose this is the point here, here is the point I want to calculate the magnetic field direction. So I will curl it like this. So you can see something is going away from me. Away from me means away from you. Away from you means into the screen, means inward. And outward is also positive z axis. This thing also you should remember. I will use this in numerical. All the things that I am doing here is for numericals only, because generally in the examination numerical will be asked. So here the direction will be inwards, and inwards is represented like this. Inwards means into the screen, and this is negative z axis. You can say into the, sorry, into the screen, or you can say away from the reader. You can also say away from the reader, observer, or here you can say uh, out of the screen. Out of the screen is positive z axis. On paper, when you will solve this question on paper, same thing will be repeated. Okay, out of the screen, or you can say towards reader or observer. You are reading, so you are of the reader, into the screen, or you can say out of reader or observer. So all things I think about the direction is clear. For me, it is also very difficult to make you understand the direction. Just last question. I want to check whether have you got or not. This is the current carrying wire, suppose. This is the current carrying wire, suppose, and I want the direction of the magnetic field at this point P and direction of the magnetic field at this point Q. Just please tell me. All of you will tell. One by one.
Point P would be inward, and for point Q it will be outward.
Outward.
Okay. So Nafisa, I am asking from you. So at point P, it will be outward or inward?
Inward.
At point P. Now, Nawal, what do you say? At point P?
Will be outward.
Outward, na?
Yes.
So if here is outward, that's at point Q. What about the point
Inwards.
Q? Inward. So Nawal is right. Why just you are you have to apply the formula like this, na? You have to apply, means you should point your thumb. Don't means you just wait a minute. Think that you are doing this by yourself. Okay, if something is coming towards you, means that will be opposite from coming towards me. Okay, so you can, if something is coming towards you and something is going towards away from you, from that you have to consider. So now see here, take your right hand. This is the condition this time. This is the condition this time. Current is flowing in this direction, and here I want to calculate the magnetic field, the direction of magnetic field, and here. So what I will do, I will point the thumb in the direction of the current, and This will be like this, and this is coming towards me, or towards me means outwards. Okay, and here when you will do this in this direction, uh, like this, means the direction of the current is like this, na? So you will do like this. Arey yaar, just wait a minute. How will you do? Huh. You will do like this, na? Current is in direction, and here is the point. So this will be away from me. Away from me means outward. So here, if you will apply on your notebook, then you will get it better. Okay. Here the direction will be outwards. And when you will apply in this direction, your thumb should be in this direction. You will apply like this. You will get it inward. Inward means this. Outward means this. Now clear, Nafisa and Matthew?
Yes,
Yes,
sir.
Okay, fine. So inward is also another name, means to, negative z-axis or positive z-axis. Inwards. Negative z-axis, na? And this is positive z-axis. Outward. Now I am telling you why we take inward this and why we take outward this. So you have seen the arrow, na? Arrow. Arrow is like this, and behind the arrow is a cross. Arrow, and suppose you can imagine. Suppose the arrow is coming towards you. If some arrow is coming towards you, this is the arrow. Okay, this arrow is coming coming towards you. So what you will see? You will just see the dot of the arrow only. You will see just dot of the arrow. So outward direction or something is coming from you is represented by this dot. Why? Because if something is coming towards you, if some this is the arrow, na? If something is coming towards you, means you are able to see only the dot of the arrow. So something is coming towards you is represented like this, and something is going away from you. So what you will see? You will see the tail of the arrow only. If suppose arrow is going away from you, you will see this cross, na? Cross of the arrow means tail of the arrow. So this will be like this. So that is why this is known as something is coming towards you or away from you. Okay, fine. Just I want to write one more point, and after that we will solve a numerical. Just note this: Biot Savart law is valid only for small current element. Small current element means you can only calculate the magnetic field at a point due to a small element of the wire only. For the whole wire you cannot get. Just copy this, all of you. And this direction part I am telling again and again is very important, very confusing also, and very important. If you will do like this and like this and like this, means the direction, whole answer will change. In one step your whole answer will change. If it is coming towards you, if you will do not correctly, then the answer will be like something is going away from you. So very careful in this. So just copy this, all of you. And one thing I want to ask you, all of you, that we need extra classes. So are you guys Can you tell me your timetable when you all are free? Matthew?
Sir, I have classes every day until other than Friday. I have every other day, every day
So,
classes.
so Matthew, you are free on? Just tell me. I am not taking your. I'm just asking on which day you are free. Friday.
Yeah, sir. Yeah, Friday.
Only Friday.
Only Friday.
And
Otherwise,
what about Nafisa? Nafisa,
I'm
tell me.
free every time after school. Same time, 4 o'clock, 3 o'clock, 4 o'clock.
Okay. And Nawal.
I'm free on Tuesday and Thursday.
Okay, no problem. It's very difficult to manage, na? Means we have to complete the syllabus also on time.
sir, I'll let you know after because I
Yeah,
have a
no
class
problem.
which is going to be
Actually, I
scheduled.
Sir,
also
on
don't. Hmm?
sir, on Sunday and Saturday I have chemistry at 4 o'clock. So
Oh,
that is the only
okay.
time I'm not free at 4.
Yeah, no problem. If there will be any extra class, so I will manage like that. You all should be free. And okay, because I think there will be a requirement of extra class. Otherwise, we will get problem. So I think it will be better to take half an hour. I should increase half an hour here. Is it fine or
Yeah, it's fine, sir.
means
It's fine.
I will increase half an hour here, not for all the time, not for all the time. Means there will actually my teaching style is like I teach slowly, slowly. I think that because I am not satisfied until the student is not get the answer. So that is why uh, uh, um, with respect to other teachers, I teach slowly because I teach each and every concept. I will try to explain each and every concept. In that thing, my time goes, and you know that your syllabus also is equally important. If I will not complete your syllabus on time, then that will also not be good. For a teacher, two things are very important: the time in which the syllabus is completing, and the things or the way of teaching, means how much you are getting from your teacher. The thing, do these two things. Now I am not saying that I am a greatest teacher. I, according to me, these two things are important. So
Sir,
have you
can you
completed?
scroll down?
Yeah.
Yeah, not no, sir.
Nafisa, Nawal, and
Sir, can you scroll down this?
yeah. Okay. Because I also do not want to take the extra classes and extra time. Because suppose if you are in an examination and there is only 3 hours, there are 3 hours only. In 3 hours, we have to complete our question paper. Means we have to write the answer in that 3 hours. No extra time will be given. But here is the situation different in case of me. I also do not want to take any 1 second extra from you. 1 hour and 30 minutes. I know that 1 hour and 30 minutes is more than enough.
Sir, can you scroll?
Yeah. Okay. Sorry. Completed this part.
No, sir, not yet.
Okay, just complete. And please write all the things properly. And this is the sign of perpendicular. And believe me, these all things are going to help you a lot when we will move in this chapter. This chapter is totally based on the direction. And this
Sir, can
part
you
takes the
scroll?
time. Okay, so Matthew, should I scroll?
Yeah, sir. Yeah.
Nawal?
Yes,
Okay. And please make this diagram, this thing more clearly. this part, especially this part, and write the unit vectors properly, because we will use these unit vectors. What is the unit vectors along positive x-axis? What is the unit vector along negative z-axis? Sorry, negative x-axis. So not today. I am not today. I am increasing half an hour, maybe from the next class, because I think you are, maybe you are not mentally prepared for that. Because after a certain period of time, the things will go out of your head. I know that. I was also the student. Still, I am a student.
Sir, can you scroll down?
Yeah.
No, sir, I'm not yet finished.
No, not finished. No. Please revise the direction part once more. Okay. You have to use your right hand and point your thumb in the direction of the current and curl your finger 90 degree. And always remember, this is valid only when you will point your fingers in the direction of a point where you have to find the magnetic field. But when you
Yes,
will
sir.
see that, when you will see the definition, okay, now I am scrolling down. When you will see the definition of the right hand thumb rule, there will be something different in that. But this thing I am telling you according to me. If I have just find this thing will be easier for the students. So I have just taken this. Because when you curl your fingers will curl 360 degree. So how can you tell the direction at one point? You have to decide the how much you are just curling your finger. You have to decide that, na. Okay. By the way, write this. One question I will solve after this, and then we will wind up. And I request you to all of the three, please be mentally prepared. Uh, in the next class, I will take half hour extra. Okay, all of you, because this is the requirement.
Yes, sir, finished.
Yeah, all of you finished.
Yes, sir.
Yes.
Okay, so just this is the current carrying wire. Okay, this is also the current carrying wire. One mark question can be asked from here. Examiner will give you the wire, and he or she will ask you the direction of the magnetic field, and he will give you a single point only.
Yes, sir, finished.
Finished? Matthew, finished?
Yes, sir, yeah.
Okay, so please note this part also. This part is very, very important, because student thought that we can find the magnetic field for the whole of the wire by using Biot law, but this is not true. Biot-Savart's law is only valid for the finding the magnetic field due to the small element of the wire only. So actually, na, one thing you can just, if you know what is Coulomb's law. Coulomb's law is for point charges, and by and point in Coulomb's law, what we find, what we were finding means the electric field was there, and here is the magnetic field. Okay, and also the magnetic field, there was the point charge, and here is point charge means very, very small charge. Here is a small current element means very small current element. So I am giving you a question for the homework. You can, if you do not know, you can check any book or you can search it from the internet or Google it. So write two similarities, and two differences. Write two similarities and two differences in, or you can say between, Biot Savart law. Actually, this is not Biot. This is only Bio. T is silent. Biot Savart's law and Coulomb's law. Coulomb's law we have discussed in the electrostatics, and Biot-Savart law we are discussing in the magnetics. So this is your question for homework, and you should add this question in your notes because this question can be asked in your exam also for 2 marks. So all of you done?
Yes, sir.
Yes, sir.
Okay, now there is a question, and after that, so there is not only the way to calculate the direction, that is right hand thumb rule. Right hand thumb rule is not only the way to calculate the direction, to find the direction. There are other methods also. There are like, if you know the cross product, then you can get the direction. Okay, so you will get that thing from this. This is the question I have taken from the NCERT. All of you know the NCERT now. What is NCERT?
Yes, sir.
Okay. So now see this question. They are saying calculate the magnetic field at the point P due to the small wire. This is the smaller element na given. This is the small current element, means in this, this is the x-axis given, this is the y-axis given, and this is the point P where we have to calculate the magnetic field due to this small length. And now please remember that we are solving the numerical, we are not discussing the theory. Okay. So we will apply our mind also. So here is the this small element. Okay, small element is there. Okay, and you have to just calculate the magnetic field at this point P. So can anyone tell me what is the direction of the magnetic field? Simply you can calculate the direction of the magnetic field. If the current in the wire, this is the small element, if in this small element the current is going in this direction, and you have to calculate the magnetic field here. So Nawal, can you tell me the direction of the magnetic field at this point P by using right hand thumb rule?
Outwards.
Yeah, of course, very good. Outwards. Outwards, Matthew, good. Nafisa, I think you have also already done it. Means outwards.
Yes.
But this is the thing you have calculated. Outwards means, what is the meaning of outward? Outward means positive z axis. Outwards means positive z axis. See here, what is positive z axis? In detail, I have told you what is positive z axis. See, the positive z axis is this, na? Positive z axis means the k vector, means like this, or outwards is positive z axis, and what is the unit vector along positive z axis? K cap. Okay, so please remember this point. So this the direction we have find it out with the help of right hand thumb rule. Now I will not apply any right hand thumb rule, and we will see whether we will get the direction or not. But we know the vector form of the Biot-Savart law. We will use I will use vector form here. dV is equal to I. We have to write the mu naught upon 4 pi also. dl cross r vector divided by r cube. Now first we have this value, we have this current 10 ampere, we have this r. What is r? R is this distance. R is given as 1 meter. Okay, I am taking it as 10 meter. R is 10 meter. But we do not have this dl vector. We do not have this dl vector. We have to calculate the dl. So see here, for calculating the dl vector, what you should have? You should have the length of the element. Length of the element is this now. Means magnitude of dl is the length of the element. So you will write this 0.01. And you will multiply this with the unit vector in the direction of the current. For the direction, you will take the direction of the current, and current is in the direction of x-axis, and along the x-axis I cap is the unit vector. So you will multiply this with I cap. So you will get the dl vector. So dl vector is 0.01 I cap. Okay. Now for the r vector, you do not have r vector. For r vector, first you should know what is the numerical value of r. What is the magnitude of r? So numerical value or magnitude of r is 10. And now you will see the direction, in which direction the r you are taking. R is this na? The r is along y-axis. This is r na? Suppose this is point O. OP is the r. And what is the direction of the OP? OP is along y-axis. So what is the unit vector along y-axis? Means j cap. J cap na? So write here j cap. So your r vector will be 10 into j cap. You should know how to make vectors from scalars. You have to write the magnitude or the numerical value, and you will multiply it with the unit vector in the direction of that. And here, how you will decide the direction? Here you have decided the direction with the direction of the current, and here you have decided the direction by meeting this O and P, because R, I have already told you, is the straight line distance between O and P. So now all the things we have, but one thing more I want to tell you, one thing more. Just wait a minute. This class is just going to finish. This is suppose I vector, this is suppose J vector, this is suppose K vector. And remember this, these are the unit vectors. These are the unit vectors. Unit vectors, I vector, J vector, and unit vectors are used for direction, for identifying the direction. So if you want to find I cross J, then first what you should do, you should decide a direction of this circle. Make this the thing like that. Make the thing like this, means you are moving in this direction. From the arrow you can get it. If you want to find I cross J, just move in this direction, you will get the K cap. If you want to find J cross K, just come to J and move towards K. J to K, and you will get this I vector, means I cap. If you want to find K cross I, if you want to find K cross I, then how you will find? First go to K and move in the circle, move on the circular path. K, I, and the next unit vector will be the answer, J vector, J cap, sorry. So now you can do this now. Matthew, Nawal, Nafisa.
Yes,
Yes, sir.
sir.
Okay, just tell me one thing. If suppose I want to find J cross I, then how you will find J cross I?
Okay.
And if no, you have to remember the direction
J.
also. No, no, no. Just I am telling. You have to move on a circle with respect to the direction that you have taken. So if you want to find J cross K, then you will move like this. J cross K, the next vector will be I. So J cross K will be I. But whenever you have to go in the backward direction, always just you want to find J cross I now. So you have to move from J to I and to K. Means this time you are moving in the opposite direction. So this time you will take minus K vector. This thing is very, very important. Now tell me, Matthew will tell. Nafisa will tell. Uh, K cross J if I want. K cross J. And always remember that here is K, here is J. So remaining vector will be the answer, but sign is important, whether it is positive or negative. So tell me, Nafisa, K cross J.
Negative I.
Very good. Negative one. Now put all the values in this formula. See, I am not using here the right hand thumb rule for calculating the direction, but this formula will tell you the direction. You will see that. Mu naught divided by 4 pi. Put the value of current. Current is given as 10. And DL vector 0.01 I cap. 0.01 I cap you will put, and this is cross of R vector. R vector is 10J. And R cube is 10 cube. Just put all the values. Mu naught divided by 4 pi is 10 to the power minus 7. And this is 10. And when you will multiply this 0.01 into 10, means you can multiply this with this, because these are the numerical values. Simply we can multiply. You will get this. You will get 0.1 only. And here you have now I cross J, and in the denominator you have 10 to the power 3. So when this 10 to the power 3 will we go in the numerator, so it will become 10 to the power minus 10, and this 10 and 0.1 will be cancelled out. Okay, how this 10 and 0.1 will be cancelled out, you can see this. When we will remove the point, so it will only remain 1. Okay, so you have this I cross J. So what is the direction of I cross J? I cross J is K vector. See this. You have got the magnetic field without, you have got the magnitude as well as the direction of the magnetic field without using the right hand thumb rule. I have not used the right hand thumb rule here. I have used just the vector. But in most of the cases, we will use, in 95% of the cases, we will use right hand thumb rule. And this question can also be solved. First, you will find the magnitude, and then after you will apply the right hand thumb rule, you will get the direction outwards. So K cap means outwards, and outwards is represented by this. And this is the magnitude. 10 to the power minus 10 is the magnitude. Magnitude means dV. dV you will get 10 to the power minus 10. And for the direction, you will say outwards, or you will say towards reader, or you will say positive z axis. Okay. Please note this question. So this type of question you should know how to solve. All of you just please copy this. Should I zoom in or zoom out? Should I zoom out or
Zoom
sorry,
out.
zoom in?
Zoom out.
If I will zoom out, then these things will not be identified by you, I think. Please remember this thing during your 12th class at least. This circular, this, na? If you are moving in the direction of the circle, then you will take positive sign of the vector. If you are moving in the negative direction, then you will take the negative sign. Throughout the 12th class, those who have the mathematics, I think if they will study the chapter, you will have a chapter 3-dimension geometry in mathematics in 12th class. So there, these things are very, very easy for those. But those who are having the bio or other subjects, they are not comfortable with these things, these vectors. And basically, basically vector is not the physics. Vector is the maths. When completed, please tell me to scroll down.
Scroll down, sir.
Nafisa and Nawal, should I scroll down?
Yes, sir. Scroll down.
Okay. So for calculating the magnetic field, you should know the magnitude and direction. And when we will move forward, we will use in 95% cases the right hand thumb rule, or there will be 5% question you will get like this. But this question also can be solved by using right hand thumb rule and this formula only. I do not have time that, but mu naught upon 4 pi I dl sin theta divided by r square. From this formula also you will get this, but you will get only this, not the direction. For the direction you have to apply right hand thumb. Okay, I think that is enough for today, and please be ready in the